Okay, let's move to our next example. Remember that when you have a complex fraction, your goal is to make it one fraction over one fraction. So in our numerator, we need to do that. So we create a common denominator. So I have a single y in this denominator and a single x in this denominator, which means I need both of those things. And it doesn't matter if you write it xy or yx. I like it alphabetical, so I'm going to go xy. And then I compare. The first denominator has a y, but it needs to be xy, which means that it's missing the x. So that's what goes up there, just like in goal 5-2. The second denominator is missing the y. So that's going to go up there. And I'm going to multiply and get 4x times x, 4x squared, minus 9y times y, 9y squared. So there's my single fraction. The denominator already is a single fraction, so we're not going to have to do any work down there. So I'm going to leave it just like it is. Because that's your first goal, single fraction over single fraction. Once it's written like this, now it goes like to goal 5-1, where we're going to flip it, one on the bottom, then we're going to do any factoring and canceling that we can as we go. All right, so the first thing up here, 4x squared minus 9y squared. Hopefully you see that as a difference of squares pretty quickly. We've done so many of those. So that's a difference of squares. 2x times 2x, 3y times 3y, a plus and a minus. Over xy, can't do anything to that denominator. It's a monomial. We're going to write a multiplication symbol now, and we're going to flip the one from the bottom. Take the reciprocal of, flip, nice easy word. So the xy is going to come up top, and the 2x minus 3y is going to go to the bottom. And you can't factor that. And then we're ready to cancel. 2x minus 3y with 2x minus 3y. Whole quantity, whole group with whole group. And then x with x and y with y. Leaving me that one lone parentheses, 2x plus 3y. With or without the parentheses, it doesn't matter.
How come we had to flip it?
Because this line right here, is a division. So it's this divided by this. And when you divide by a fraction, that means you're going to have to flip the one. Typically behind the division symbol, back in goal 5-1, we had that division symbol. Here, it's the same kind of problem written as a complex fraction. It still means divide.
Did we do that on the other one?
Yeah.
No.
Okay. Okay, next example. In the numerator, so the x minus 20 over x plus 1. Common denominator, there's only one denominator there, is x plus 1. So that's a group. If you want to put it as parentheses, feel free to do that. So this first denominator, which is understood to be a 1, or doesn't exist there, doesn't have a denominator, so that means it needs the x plus 1. Second denominator looks exactly like that, so I don't need anything up there with that 20. So I'm going to multiply through. X times x is x squared. X times 1 is 1x. And then minus 20 comes over. We didn't multiply it by anything. And then I do the same thing in the denominator of the complex fraction. The common denominator is x plus 2 because it's the only denominator there. First denominator, which doesn't exist or is understood to be a 1, needs that x plus 2. The second denominator looks exactly as the common denominator, so I don't need anything with 15. So I'm going to distribute and have x to the second, x times x times positive 2x, and minus 15 comes over. And now we're back to what goal 1 was like, where we're going to be factoring and canceling. Factor, cancel. It's just written differently, but it's a division still. All right. So up here, x squared plus x minus 20. We start by factoring that. I want to get a 1 in the middle, so think of your combinations for 20. You got 20 and 1. You got 10 and 2, you got 5 and 4. So we're going to use 5 and 4 because we want to get that 1. So x plus 5 and x minus 4 give me that 1 in the middle and also my 20. X plus 1, you can't do anything to that. And then we're going to flip the one on the bottom because we're dividing by a fraction, so we flip this. So x plus 2 comes up top. And then we're going to factor x squared plus 2x minus 15. 15 can be 15 and 1 or 5 and 3, my only two choices. I want to get positive 2 in the middle. So we're going to have positive 5 and minus 3. That's going to give me my positive 2 in the middle. And then I cancel whole groups. X plus 5 with whole group, x plus 5. Not much canceling there, that's it. Don't literally multiply these out just like before, leave them in parentheses. So everything that's left is my answer. And then my last example, it's already ready for us. It's already a single fraction over a single fraction. So we're ready to flip and factor and cancel already. So the numerator, 3, can't do anything to that. The denominator, x minus y, can't do anything to that. So we're ready to flip this now. X squared minus y squared is going to go to the top. This is a difference of squares. So it's going to factor into x times x, y times y, plus and minus. And then the 9 comes to the bottom. And then we're ready to cancel. X minus y with x minus y, whole group with whole group. And then 3 divides into 9 3 times to itself once. Leaving me x plus y over 3. Okay, so again, first you're using addition and subtraction, making common denominators to get it to be a single fraction. So that's like we did in goal 5.2. Once you get those single fractions, then we go to 5.1, where we factor, we flip, and we cancel. It looks different, but it's the same as 5.1. The division is just written as a complex fraction instead of with the division symbol. Okay?